a small remark. The Reynolds number we used just now, we can call it to be REL because the characteristic length was this L, right? It was UL over nu. Well, you see both U and L are the constants depicting the conditions in the whole fluids, right? In the whole system. So we can say the REL is the overall Reynolds number that depicts the flow conditions in all the fluids, right? But we can also define another kind of Reynolds number. Let's say Reynolds number with an index x. This means our characteristic length here is not L but x. So this thing will be U times x over nu. We can use yet another length to depict the flow conditions, which is delta. If we use the delta to be the characteristic length, then the Reynolds delta will be U delta over nu. Of course, these two are directly related, right? Because we know delta is a function of x. Okay, so what's the difference between this kind of Reynolds number and this kind? Do you agree that in this kinds of Reynolds number, we are considering the flow conditions at some specific x, right? At some specific x. So if we want to consider, or if we want to study the effect of our flow conditions transition from laminar to turbulent, then we need to consider which kind of Reynolds number? This kind, but not this kind, right?